My name is Gary Wilson. I'm here in Offshore New Harbor Camp, working as part of the team to investigate what lies beneath us now using the tool of gravity. We have a meter that responds to mass, and the bigger the mass, the greater the response on the meter. And so we move around with that meter mapping that response. We all know that when you drop something, it falls to the earth, and that's the gravitational attraction. And that's the mass of whatever you've dropped being attracted to the mass of the earth. The speed, though, that thing that you've dropped falls is solely dependent upon the mass that you drop and the size of the mass of the earth. And if you're closer to some more dense material, it's got greater mass, and so that thing that you drop will fall slightly faster, ever so slightly. It's a minute difference, but the meter that we have is sensitive enough to measure that difference. And so we use gravity as a tool to investigate the sediments, the rocks beneath us. The way that this meter works to measure that gravitational attraction is that there's a finite length spring in here. It's got a mass on the end of it, and it measures the slight difference in attraction of that mass down to the earth. So that's what we were talking about with something falling to the earth. But this is on a spring, and we can measure the very exact length of change in length of that spring. There, you see that moving? That's responding to the ocean movement underneath. The dial gives us the exact value, or the relative value, if you like, of gravity that we then tie back to the base station. And so a set of measurements during the day would mean measuring this at the base station at camp, going out to your points in the field and making measurements there, and then coming back to the base station and tying that loop together and constantly closing loops of the survey.
This is the map of the gravity anomalies that we've been measuring. The darker blues are absences of gravity, unusual lows. The light colours, the yellows and the reds, are gravity highs. And so what we've got is a general trend that goes from high to low going in towards the mountains. And then what we're interested in is the little patches like that and that, where there are bits of the anomaly that step out from the general trend. And that shows that there's some kind of structure or sedimentary basins, which is what we're looking for.
The difference or commonalities between what we're doing with the gravity survey and the seismic survey is that we're focusing two complementary geophysical techniques on the same problem. So the seismic survey is imaging the seafloor and the layers of sediment that are sitting beneath the seafloor. And we'll take the information about where the seafloor is and then make some calculations about the dense rocks underneath the sediment and how close they are to the seafloor. So we can apply those two techniques to the same problem and get slightly different but complementary information. So it's all about using techniques to work out what sits underneath this floating ice in this ocean that you can't actually see, but we can use these geophysical techniques to image what's down there below the ocean.